All right, guys, we're going to wrap up this lesson by simplifying some radical expressions. All right, so we have 10 plus 5 times the square root of 50 minus 3 times the square root of 98 plus 12. Let's get the easiest part of this first. Let's go ahead and add the constants. So 10 plus 12, that's 22. Let's take care of that really quickly. All right, as far as the radicals are concerned, now listen carefully. We are not allowed to add or subtract radicals unless they are considered like radicals. In order for two radicals to be considered like radicals, and then you can combine them, is if they have the same index and the same radicand. Okay, and so you can see that these two radical expressions here, they already have the same index. This is a square root and a square root, right? So the index 2, index 2. So that's good, but the radicands are different. And so this is the idea, everybody. Let's simplify this radical, and then let's also simplify this radical using the techniques we were just talking about. And maybe after simplifying each one, then maybe we'll have like radicals that we can combine. All right, so let's check this out. So I'm going to rewrite 50 as 25 times 2. I'm going to rewrite 98 as 49 times 2. Remember, you want to rewrite 50 as a product of two factors where one of them is a perfect square. 25 times 2 will work. 98, rewrite it as a product of two factors where one of them is a perfect square. 49 times 2 will work. So what we have then is 22 plus 5 times 5 times the square root of 2 minus 3 times 7 times the square root of 2. Or 22 plus 25 root 2 minus 21 root 2. There, you can see hopefully now that this radical expression and this one here are considered like radicals. They have the same index. The indices have been the same since the beginning, right? But now the radicands are the same, 2 and 2. So what we can do now is combine these two. And how do we combine them? The same way you combine like terms. You add or subtract the coefficients. 25, positive 25, minus 21 is 4. So then I have 4, and then you keep the like part, root 2. So this is your final answer, 22 plus 4 root 2. Check this one out. We have the cube root of 40 plus 2 times the cube root of 135 minus the cube root of 250. Now, what I'll do is I'll simplify each one of these, and hopefully after doing so, we'll have like radicals. Right now, at least all of the indices are 3, right? Index 3, index 3, index 3. That's good, but the radicands are all different. So the idea is, these are not like radicals right now, but maybe after we simplify them, we'll see we do have like radicals. I'm going to rewrite the number the number 40 as the cube root of 8 times the cube root of 5. Remember, you want to split 40 up into two factors where one of them is a perfect cube, and 8 is that perfect cube. Plus 2 times. Now, I am going to rewrite 135 as a product of its prime factors. So come with me down here. Now, you don't have to do the factor tree if you don't want to. But 135 is 5 times 27, okay? And then, 5 is prime. 27 is 3 times 9. Of course, 3 is prime. And then 9 is 3 times 3, right? Let's see if I can fit this here. Yeah, I got it. So 3 times 3. So you can see that 135 is, it is 3 cubed times 5. So that's how I'll rewrite 135. 3 cubed times 5. I'll do the same thing for 250. So I'm going to bring 250 down here. This is 25 times 10. Any number that ends in a 0 is divisible by 10. Neither 25 nor 10 are perfect cubes, so I'll keep going. 25 is 5 times 5, and 10 is 5 times 2. All of these are prime now. So I can rewrite 250 as 5 cubed times 2. So here we go. The cube root of 8 is 2 times the cube root of 5 plus 2 times. Now the cube root of 3 cubed, remember the cube root and the third power cancel, so it's just 2 times 3. But the cube root of 5 must stay, minus 5 times the cube root of 2. Again, the cube root and the third power cancel. So then we have 2 times the cube root of 5. That is the cube root. Now, I don't know. I think that looks sloppy, so let me make sure that looks like a 3 there. Better. Plus 6 times the cube root of 5 minus 5 times the cube root of 2. All right, each radical has been simplified, but notice that the only like radicals are the first two, because their radicands are the same, but this radicand is different. So these are the only two that you can combine. Now, remember how to combine like radicals is by adding or subtracting their coefficients. 2 plus 6 gives you 8. Keep the common or the like part, bring down this last term over here. So your final answer is 8 times the cube root of 5 minus 5 times the cube root of 2.